You're watching the Mr. Quality Guy YouTube channel. Hello everyone, Mr. Quality Guy here, and today we're going to do a video on tolerance stack-ups and what they mean. So, sit back, relax, and we'll get right into it. Alrighty, so when it comes to tolerance stack-ups, there are some things that we need to consider, and we need to understand what is a tolerance stack-up. So, stack-ups are simply put as a way to control quality. So product manufacturers utilize an organized flow of information to translate customer requirements into product requirements. This process for stack-ups are vital to address mechanical fit and mechanical performance requirements. Mechanical fit is simply answering the question, do the parts that make up the assembly always go together? And so that gets us into a flow chart of what product requirements are. And so if we look at the chart below, we can see there's product requirements, design failure mode, and effect analysis, mechanical requirements, mechanical fit and performance requirements, and we have to establish acceptance limits on performance requirements. So all of these are things that actually go into manufacturing. All these things need to be considered. So when it comes to product requirements, what does the customer need our product to do? When it comes to design failure mode and effects analysis, we need to understand what are all the possible failure modes for our product. And mechanical requirements, we need to ask ourselves, what do we need to control in the assembly to achieve the customer requirements? And when it comes to mechanical fit and performance requirements, we also have to ask ourselves, what are the specific gap and alignment requirements between parts to achieve customer needs? And when we go to get our acceptance limits, how much gap and alignment variation is allowable? All these are requirements that we need to understand and ensure that, hey, this is what the customer wants. But that's not all. Tolerance stack-up calculations represent the cumulative effect of part tolerance with respect to an assembly requirement. The idea of tolerances stacking up would refer to adding tolerances to find total part tolerance, then comparing that to the available gap or performance limits in order to see if the design will work properly. This simple comparison is also referred to as a worst-case analysis. Worst-case analysis is appropriate for certain requirements where failure would represent catastrophe for the company. It's also useful and appropriate for problems that involve a low number of parts, low being defined as 3 or 4 parts. Worst-case analysis is often done in a single direction, i.e. a 1D analysis. If the analysis involves part dimensions that are not parallel to the assembly measurement being studied, the stack-up approach must be modified since 2D variation, such as angles or any variation that is not parallel with the 1D direction, does not affect the assembly measurement with a 1-to-1 ratio. And that's where we need to get into why this is important. So tolerance stack-ups and or part stacks are important as if done properly and all the components are in tolerance, there is no reason for a no-build situation, i.e. parts do not fit together at this point. That is an issue where parts don't fit together and all your stack-ups are good, then that tells you you have a process problem. And by doing that, you make life easier for yourself in finding the issue quicker. Anything that you can do to pull out a variable or a variable that you can control, you're going to get your answer sooner. So, I'd like to thank you guys for watching. Thank you and have a nice day. Alrighty, so that was a video on tolerance stack-ups. I hope you guys enjoyed. Thank you and you have a great day.